Hello, my name is Giron. I'm going to present my Project2 presentation. I'm going to show you what I researched, my code, and my results. So last homework we went over Q-learning. We used Q-learning to solve the taxi problem, which, if you recall, we had 500 states. Basically, the state space was 500. And so it was a limited number, which we were able to use Q-learning, which basically uses a function approximator. We'll go over that in a second. And the function approximator is a table lookup. And so given the state in action, it'll go back and pick the maximum Q value from the table and update the values and iterate over and over using this algorithm. And using that algorithm, it'll optimize the policy, which will maximize the reward using the Bellman equation. And so what happens if we have a continuous state space? And that meaning, so here we're in a grid, it's not going to go diagonally, it's only going to go straight up, down, and there's only a certain number of states it can be in. But what about the cart pole problem, where it can be tipped over 1 degree, 2 degrees, 1.5, like going left, going right, this how fast, how slow, and same thing with the lunar lander problem. It could be going even more continuous state space, more infinite space. So yeah, so it's more complex. So we use deep Q learning, which will be experience replay. And using that, it'll be able to help with the continuous state space, and it uses a function approximator from David Silver's lecture. Lecture 6 is really good. He showed us how we could use supervised learning, such as neural networks is what we'll be using, or it could be KNN, regression, decision tree, you name it, to use that to help with your reinforcement learning problem. So back to and we're going to use this to update the algorithm. This is going to be the algorithm that's in my code basically. What it does is it goes through and it, based on the epsilon greedy right here, it'll, given the previous actions, it'll predict which one's the best action to take, and they'll take that action, and then it'll go through, find the next step and the reward, and it'll store that into the data set, and then we'll use that again to train on. And so when we train on the data set, it'll update the Q values based on the function approximator. And so here's my code. Parameter tuning is huge. I'll just run it really quick. I'm not going to really get into it, but so right now it's at this is the learning rate, the batch size 64, more parameter tuning. I use epsilon a lot. This is the decay rate, so it starts at 1, goes down to really low. There's different ways you can tune this problem, and you have to see in the beginning. You'll do lots of exploration. You need to do lots of exploration, or else it won't work. You won't get the results you want. There's the epsilon. What was I going to show? Oh yeah, the neural network. That's also, I feel like that's a key part. How you set up your layers. Right here, I just had it set up to where the number in the state space cubed, which worked well for the cart pole problem. It worked a little bit slower in this problem. It still got me some results I wanted. The lower this is, the more consistent it was, the higher this loss or learning rate came in the neural network. The higher it got, the less consistent it went, so I kept it pretty low. Gamma stuck the same. There's so many different things I could have tried, or it just takes a while to even train this thing. So in my results, even this right here, this is after 8 or 9 runs of saved results, saved weights for my neural network, and even then it wasn't perfect, but I was able to get, after using that really low the epsilon decay rate, I was able to get to suitable total rewards, and so I was happy with that. I wasn't able to get the epsilon is 0, the rewards I wanted. It all comes down to parameter tuning, I think, and also the neural network. Just different things you can try. There's a lot, which makes this exciting thing to talk about and think about. But yeah, there's my project. You can read it if you want. Thanks for listening.